Hi gents, we're gonna have a quick little look here at Surds because people were asking just to do a little bit of revision on it. So that's what we'll do. What we'll just look at is we'll look at a few rules of Surds, just the very beginning. So if you've got root 6 and you add on, for instance, root 3, there's nothing really that you can do here. Okay, there is no way to make this so much better. So what you're going to have to do is you're going to have a look at when can you add surds together. For instance, if I did root 6 times root 3, can I get an answer there? And there is one. There is a rule. It says root a times root b is equal to the square root of a times b. So this is the square root of 6 by 3, or just root 18. Okay, simple as that. Now we come across another rule here. We can use that thing as well, which is root a times root b equals root of ab. Because what you can actually do here is you can break up root 18 into root 9 times root 2. So we can call it 3 root 2. Okay. And this makes sense actually if we just come across over here. That root 6 you can break down into root 6 as root 2 times root 3. That's what root 6 is. And what was it multiplying by? It was only multiplying by root 3. And so we have root 2 multiplied by root 3 times root 3. That is to say root 3 squared. Best 3 going on there. Square and square root are opposite functions to each other. That's just 3. So we have root 2 times 3, or 3 root 2s. Okay, so you can think of it in several different ways. Okay, let's just take a few examples that they have here. We can only add, by the way, that was multiplication. We can only add root 3s to root 3s and so on. So let me give you an example. We'll take root 20 added to root 45 plus root 18 minus root 50. Okay, so what we want to do is we want to add all of these things together. So in order to be able to add them together, what we need to do is we need to break it down. Okay, we're going to break down each one. So root 20, now there's a couple of ways you can break it down into root 2, root 10. But that's not helpful. Let's look at the roots that are helpful. If you had root 9, for instance, that would be 3. If you had root 16, that would be 4. If you had root 25, these are the helpful roots. Okay, you're looking for a root for it, and these are of course the squared numbers. So actually a better one to break down into is 4 and 5, because the square root of 4 is 2. Excuse me. So it makes absolute sense to go and write that particular one down. Okay, root 4, root 5 makes total sense to write down, just like here. Root 9, root 5 makes perfect sense to write down. Excuse me. And over here, well, 19, root 9, root 2. And here minus root 25, root 2. So here we have 2 root 5s added to 3 root 5s, added to 3 root 2s, take away 5 root 2s. Well, if you've got root 5s, if you've 2 root 5s and 3 root 5s, you've got 5 root 5s. And if you have 3 root 2s and you take away 5 root 2s, you have minus 2 root 2s. Sorry, I meant to say root 5, so I was jumping ahead to what we were going to be doing there. And from here, there's nothing you can say. Okay, this isn't 3 of anything in particular. Okay, you just have 5. It's kind of like having 5x minus 2y. Okay, you wouldn't call it 3 blah or anything like that. You just say that that is what you have. Okay, time for you to give one a shot here. Root 72 plus root 48 plus root 8 minus root 12. I want you to write that down as best you can. Pause the video there and give this a shot. Okay, well oftentimes, you know, it's easier just to go with the smaller ones where there are fewer options. You know, 6 and 2 here, it's no good because 6 and 2, none of them are nice square roots, but 4 and 3 works. So you know that you're going to be dealing with a root 3 here. That, you know, that's going to be useful some way along the line, I would think. here we have, okay, minus on that one, here we have 4 and 2. So it looks like we're going to be dealing with root 2's somewhere along the line. Okay, so does it make sense? If I were to do a root 2 here, for instance, what would I get? 24. Okay, nothing especially nice there. So maybe a 3 works out on it. Okay, maybe 3 goes into it. Because, you know, you got to be smart. We're going to be adding root 3's to root 3's. Now, why didn't I like root 2's to root 2? Because the root 24 wasn't anything nice. But if you take 48 and divide it by 3, you'll see that you get 16. And look at that, that is a nice number. And I bet this is going to be a root 2 and something nice. And of course, if you take 72 and divide it by 2, it's root 36. So here we have 6 root 2's added to 4 root 3's. That was added to 2 root 2's minus 2 root 3's. Okay, how many root 2's we have? We have 6 of them and we have 2 of them. We have 8 root 2's. How many root 3's do we have? We have 4 of them. We're taking away 2 of them. We have plus 2 root 3 of them. Okay, and that's it really when it comes down to surds. Those are the main properties that you are dealing with. Okay, how to add and subtract them. We might just do one little thing here just to maybe show you some stuff that you could do. How would you simplify 15 over root 5? Okay, how would you simplify 15 over root 5? So things that you can't do, you can't square top and bottom of a fraction. Yeah, if you could, a half would be a quarter. If you squared the top and squared the bottom, and we know that that's not true. But you can multiply top and bottom by the same number. So what do you think we should multiply top and bottom by? Hopefully you said root 5. Because the top by root 5 will be 15 root 5's. And the bottom by root 5, well, root 5 by root 5 is just root 5 squared, or 5. And 5 divides into 15 to give 3. So we have 3 root 5's. So another way to say 15 over root 5 is to say 3 root 5's. Okay, simple as that. We might just go and do a little bit of multiplication. Let's say this one here. These are all maybe just a little bit too easy, if I dare say so myself. Here's a nasty one. K times 5 plus root 3 times 5 minus root 3 equals 66. Find the value of K. All right. You've got a few ways to do this. You could just multiply this thing out here. That's maybe the easiest way to do it. So it's K times, we'll just do that. Okay, 25 minus 5 root 3's plus 5 root 3's. That'll give us nothing. And this will be minus root 3 by root 3, so it's just minus 3. And it's equal to 66. So we have K is equal to, well, that times that, or is that added that is nothing. And we're left with 22 here. It's equal to 66. So we have 22 K's. It's equal to 66. 22 times the number equals 66. Divide both sides by 22. You get K equals 3. Okay, so those are surds, and that's our little revision of them. Plenty of questions on page 35 of your book. The other one that I was asked to do was to do changing the subject of a formula. So we'll just have a look. Here's one. V squared equals u squared plus 2as. This is an actual thing from physics. And what it's asking us to do is it's asking us, in this case, to write, what it'll say, write A in terms of, so what it means is it wants A equals, in terms of all the other things, V, U, and S. Okay, here's the trick. Whatever you want, we want an A. Everything that has an A in it, there's only one thing in here, but everything with an A in it to one side, everything else the other. So V squared minus U squared is equal to 2AS. We subtract U squared from both sides. And now we want to get a on its own. Divide this by, what would you divide it by? Well, 2s. So you have to divide this by 2s. So on the right we just get a, because that's what we wanted, and on this side we get v squared minus u squared over 2s, and it's done. Okay, I think we'll favourite one of these, if I'm allowed to have a favourite. 1 over u plus 1 over v equals 1 over f. Maybe you've met this in physics. What to do here? Well, let's say we're asked, I'm going to write what we are told to get. Let's say we're asked to get v equals. Okay, write v in terms of is what they will say. Write v in terms of u and f. What you want to do here is you want to get rid of the fractions. And the way to do it is to multiply everything, each term or both sides, by u, v, and f. Whatever is on the bottom. So watch me now. This is the most important thing that we've been doing for quite a while. What have I done? I've taken this number here, whatever it is, and multiplied by UVF, and I've taken the other number there and multiplied it by UV and F. Okay, let's do this real slowly. I'll call this over 1. We're going to multiply it in. So top by top, UVF, bottom by bottom, bottom by bottom, U, plus, we'll do the same over here. We get UVF over V. And here, it's over 1 again. So UVF over F. Now, you wouldn't have to write that out, but watch what you get. U divides into UVF to leave even VF. V divides into UVF to leave UF. And F divides into UVF to leave UV. We want to get V equals. Remember what I said. Anything that has a V in it to one side. So UF is equal to UV minus VF. So V over to one side. Now the real important thing to do here. If you have two V's, factorize U minus F. Now to get V on its own, you simply divide both sides by U minus F. So we get V is equal to UF over U minus F. And that is changing the subject of a formula. Maybe here's one for you to try yourself. Or is equal to 1 over, this is an S, plus T, and it wants you to get S equals. Okay, pause the video, give it a shot there. Okay, there are many ways to start. Excuse me, I am going to start by multiplying everything by S. Or S is equal to 1 plus TS. I think that is a very good way to start. Okay, multiply both sides by S. It just gets rid of the fraction. You don't have to worry, you don't have to worry about it anymore. So it's S times both sides. Okay, S by or, S or, S is S over 1, so this by this, that's S over S, and that by that is ST over 1. Okay, if you really want to do it really slowly, so S or is equal to 1 plus ST. We want an S equals, so everything with an S to one side, there it is, or minus T equals 1. Divide both sides by or minus T. Okay, what I would suggest you do is give a few goes at on this page, page 56, okay? And any questions that you have, of course, send them to me. As you know, I'm happy to do them out free. Okay, gents, that's it. Best of luck.